Hello everybody, today we're going to have a look at some more trig equations. This time we'll look at quadratic ones in particular. So just two examples today. Have a look at the first one. We have 2 sine squared x plus sine x is equal to 0. We're solving this for a boundary of 0 to 2 pi. Okay, so the trick with these is to think of them as just quadratics before you do anything with trigonometry at all. So to help us with that, let's imagine that a sine x is just a y. So if that was true, then what we would be solving is 2y squared plus y equals 0. This looks much more comfortable and familiar, so we can just use our usual processes to solve this. I would probably solve this by factorizing. So I take a factor of y out and rewrite it like this. And if we have two numbers multiplying together to make 0, then one of them must be 0. Either y is equal to 0 or 2y plus 1 is equal to 0. Or in other words, sine x, if we make that swap back again, is 0. And I'm hoping you can see that in this case, sine x is equal to negative a half, just by rearranging, moving the 1 across and dividing by 2. Okay, so from there, we should know what to do because we've got plenty of experience using the unit circle now. So sine is, of course, the y-axis on that unit circle. That needs to be 0. So when will that be 0? Well, it's going to be 0 when we have the angle x, in this case, equal to 0. It's also going to happen when we have the angle equal to pi, and again, when we're all the way around back at 2 pi. So 0, pi, and 2 pi are all solutions from the first possibility of that sine x being 0. Sine x being equal to negative a half, we're going to do that separately. So negative a half on our on our y-axis for sine. Well, that is going to take place at a couple of positions over here. Well, that will be at x is equal to 7 pi over 6. That's the full rotation around pi plus the pi over 6 from the special triangle. If we come backwards, see there's pi over 6 going to be here. If we take that away from 2 pi, we'll get our other solution. That's going to be 11 pi over 6. So we have 5 separate solutions for that original equation. 0 pi, 2 pi, 7 pi over 6, and 11 pi over 6. Okay, let's do the second example. This one has some cosines in it. It's going to be the same sort of idea as last time. We're going to say that cosine x is going to be equal to y, and let's kind of ignore the trigonometry for a moment, and let's just focus on the quadratic equation generated. So that'll be something like this. I teach these via the target number method. So we multiply the coefficient of the y squared and the number on its own by together. So that is going to be our target number of -2. We think of two numbers that multiply to make -2 and add to make the coefficient of that middle term. So 1 in this case, well, that's going to be 2 and -1. And then we're going to split up the quadratic into, the middle component of the quadratic into those two pieces. So our original quadratic will be equivalent to 2y squared plus 2y minus 1y minus 1. And then we're going to factorize the left and factorize the right, and we are aiming to have the same items, the same terms in the bracket. So we'll have 2y taken out of the left-hand side, and we'll be left with a y plus 1. On the right-hand side, if we take a -1 out, we'll be left with a y plus 1 as well. And so, if you remember, if we have a 2y multiplying a y plus 1 and a -1 multiplying a y plus 1, then overall what we have is a 2y minus 1. Those two pieces, look, are fitting into this bracket, and they're, of course, multiplying a y plus 1. Okay, so we've managed to factorize it, and from here we can get our solutions, because two numbers multiplying together to make 0 means that each one of them certainly has to be a 0 as a possibility of an answer. So this tells me that y can equal to a positive half, or y is equal to -1. That will make the bracket 0. Of course, we remember that y's are actually cosine x's. So in fact, what we have is cosine x equal to a half, and cosine x equal to -1. So this is the x-axis on our unit circle. So we should be thinking along those terms. So imagine our unit circle, our x-axis is going to be at a half, right? So we're going to have a situation like this. There's our half there, look. So when is that going to happen? Well, clearly it's going to happen at pi over 3 using our unit circle and our special triangles. And the other one, okay, so right round to this angle, well, I'll just take a pi over 3 away from 2 pi to get the other one, and that's going to be at 5 pi over 3. What about the other solution where cosine of x is equal to -1? Well, that x coordinate is at -1, right around there at pi radians. So pi radians is going to be our other solution within this boundary. So for this one, we have 3 solutions: pi over 3, 5 pi over 3, and pi. Okay, that should be enough to have a go at some of these questions. Good luck.